Okay, question 1. So this is a fairly typical exam question, relatively straightforward. So part A says, what energy must an electron absorb to move from the ground state to the second energy level? So it's told us specifically what the two energy levels are, and this is in joules rather than EV, so it's just the difference between these two. As mentioned before, if you'd rather ignore the negative sign to make life easier, that's absolutely fine. It's just the difference between the two, but make sure you include the 10 to the minus 19. That's very important. B, straightforward. We know E equals hc over lambda to make lambda the subject, hc over E, and we've got Planck multiplied by speed of light divided by your previous value, and you're going to get the wavelength as shown. So an exam tip here would be make sure you show all your working out, because in a multi-stage calculation like this, if for some reason you made a mistake in part A, but you didn't show all your working out in part B, you would get 0 marks. If you show your working out, you get error carried forward, and you should get full marks even if your answer is incorrect. C, if the electron falls from the 4th energy level, how many different frequencies could be emitted? Well, we talked about this before. So we could go from 4 to 3, 4 to 2, 4 to 1, that's 3. If we're at 3, we could drop down to 2 and then down to 1, or we could go all the way down to 1. So there are 6 possible frequencies, 6 possible wavelengths. So that corresponds to 6 lines on our spectra, whether it's emission or absorption. Right, question 2, another fairly typical exam question. So it tells us we've got 3 energy levels here, and it tells us what's going on. The electron jumps from 1 to 2 and then back down to 1, so absorbed and then re-emitted. Calculate the frequency. Okay, so we need to look at the difference between these two energy values. We can ignore the negative if you prefer. So the difference is 10.19 eV. We need to convert that into joules, so multiply by 1.6 10 to the minus 19, and that is our value in joules. And then we're trying to find the frequency, so we know E equals hf, make f the subject, so it's going to be your previous answer divided by the Planck constant, and we get our frequency as shown, 2.46 10 to the 15. Part B, show that the original photon cannot excite the electron in the ground state to the 3rd energy level. Right, so this is the idea of particular transitions correspond to particular energies of photons. So if we work out the energy difference between 1 and 3, so 13.6 take away 1.51, 12.09. If we compare that to the previous value, which is 10.19, then it's obviously a different value. So all we need to say is the energy difference is a different value, therefore the first photon will not correspond to this transition between 1 and 3. Right, C, when they're excited to the 3rd energy level, we get multiple frequencies. Okay, so once again, this is similar to what we were saying before. So if it's in position 3, it could drop to 2, or it could drop to 1, or it could drop from 2 to 1. So there are 3 possible transitions. They're very similar to what we said previously.